Hello students, how are you all? Welcome back to the third video of laws of motion. In previous session, the second video of laws of motion, part 2, we did solve numericals up to question number 55, right? Okay. Let's solve question number 56. Okay, let me read it out. So what is the data they have given? A roller coaster is designed such that riders experience weightlessness as they go around the top of a hill whose radius of curvature is 20 meters. The speed of the car at the top of the hill is in between. Let me consider this is a hill and a roller coaster is going on overhead here. Let me consider mass of that is m. At this point of contact, object is feeling weightlessness. That means there should be upward force, and that is equal to mv square by r as it is moving on a circular path. Weight of the body and centrifugal force both must be equal. Then only net force acting on that object will be zero, and that object will feel weightlessness at that point. Okay, so let me equate these two forces. For weightlessness, these forces must be equal. That is mv square by r must be equal to mg. M will get cancelled. We need to find out velocity. Okay, so our speed. So v square is equal to r into g, and v is equal to root rg, where r is 20 meter. Okay, so v is equal to root of 20 meter. Let me take a g value as 10. Then v is equal to root of 2 into 100. 100 will comes outside. It is going to be 10 root 2. So we know the value of root 2. Root 2 is 1.414. Sorry. What's the value of root 2? Root 2 is 1.414. Let me represent that. So root 2 is 1.414 and 1 by root 2 is 0.707. Please remember, it will help you in solving numericals. Root 3 value is 1.732. 1 by root 3 value is 0.577. Remember these values. Okay. So if you substitute root 2 value here, it is going to be v is equal to 10 into 1.414, which is equal to 14.14 meter per second, which is lying between 14 meter per second and 15 meter per second. That is, so this is in between 14 meter per second and 15 meter per second. Okay, this is going to be the answer. Which option matches? Option C is the correct answer. Okay, very good. Let's move on to the next question. Question number 57. Okay, question number 57 solution. So which question we solved? We solved on 56, right? Okay, sorry. Let me read out the question. A tube of length L, okay, is filled completely with an incompressible liquid of mass capital M and closed at both ends. Okay, super. This is the tube. They have it is given. The tube is then rotated in a horizontal plane. Okay, so now this tube is rotated like this with some angular velocity. Okay, so which is omega. So let's say it is rotating about length L by 2. Okay, now what's the question they're asking? The force exerted by the liquid at the end is, okay, super. So whatever the fluid which is inside this tube tries to move towards left. Okay, so with some force, that force we have to find out. So what's the formula for centrifugal force? That's the force with which that mass will move towards left. Centrifugal force is equal to mv square by r, or else you can replace it as m omega square r, where r is L by 2 here. So answer is going to be m omega square L by 2. So which option is matching for question number 57? Option C is correct. Is that option C or option B. Option B. M omega square L by 2. Okay. Let's move on to the next question. The next question they have given 58. Okay, let me read it out. A 500 kg car takes a round turn of radius 50 meter with a velocity 36 km per hour. Okay, let me represent that round turn. So what's the mass of the vehicle? Mass of the vehicle is 500 kg. Okay, mass of the vehicle is 500 kg. So what is the radius of this path? The radius of this path is 50 meter. Okay, and it is moving with a speed of this vehicle is 36 kilometer per hour. Try to convert this 36 kilometer per hour in terms of meter per second. That is kilometer per hour can be converted into meter per second by multiplying it with by 5 by 18. 36 into 5 by 18. 18 ones and 18 twos. So which is equal to 2 5s 10 meter per second. This is the velocity with which car is moving on this circular track. So how to find out centripetal force? What's the formula for centripetal force, guys? Centripetal force is equal to mv square by r. So here, what's the mass of the car? 500. Velocity with which it is moving? 10. 10 square, it is going to be 100 divided by r is equal to how much they have given? 50. Super. So 50 ones 50 tens, it is going to be 1000 newtons. This is the centripetal force acting on that part. So which option is correct? Option A is correct. Super. Next, question number 59. A ball of mass 0.25 kg attached to the end of a string of length 1.96 meter. Okay, question number 59. So there is a string and a ball is connected. What's the mass of the ball? They have given 0.25 kg. Okay, length of the string is going to be 1.96 meters. Super. Is moving in a horizontal circle. The string will break. Okay, so now it is moving in a horizontal circle like this. Okay, super. What's the question? The string will break if the tension is more than 25 newtons. Okay, super. So they have already given maximum value of tension and it is equal to 25 newtons. If this exceeds this, if the centrifugal force exceeds this tension, then definitely string will break. So what is the maximum speed with which the ball can be moved? Okay. What is the direction of centrifugal force acting on this ball? Centrifugal force acts away from the center and it is equal to mv square by r. So if equate both of them, then we are going to get velocity with which that ball should be rotating. Okay, so let's say this velocity is v. Now T is equal to mv square by r. Tension in the string is represented as 25. Mass of that block is 0.25 kg. 0.25 kg can be represented as 1 by 4, right? Yes, it is into v square. We don't know. That's what we have to find out. What's the value of r? R is 1.96 super meter. So v square is equal to, you can write down it is as 25 into 1.96 into 4. So v square can be written as 25 into 4, it is going to be 100. 196 by 100. 100 will get cancelled. Then v is equal to 14 meter per second, and this is going to be the answer. Which option matches for this? Option C is the correct answer for question number 59. Hope you understood. Next, let me move on to the next question. That is going to be 60 question number. Now, question number 60. When a milk is churned, cream gets separated due to definitely centrifugal force. Okay, so let me consider a glass. If I consider a glass like this, and if milk is present inside and if you are churning it, that means it is moving like this. So there is a possibility that this milk may fell out because of centrifugal force, not because of centripetal force. Centrifugal force is the responsible force for the objects to fall out of the circular motion. So which option is correct? So for question number 60, option B is correct. Hope you understood, guys. Okay, let's move on to the next concept, a very important, and so many students used to get confused in this concept. Let me give you a clarity, so try to understand each and every step that I am going to represent. Before solving this question, I would like to give you one short notes, like a trick. So let me give you a trick. The trick is, so let me consider a pulley system, a block of mass m2 and another block of mass m1 is connected here, and m1 is greater than m2. This is what my assumption is. Okay, as m1 is greater than m2, definitely system will accelerate. So m1 will accelerate downward with an acceleration a, m2 will accelerate upward with an acceleration a. So both the blocks are having same acceleration. Let me represent weights acting on that object. So weight of this object is m1g and weight of m2 block is m2g. Tension in the string of m1 is T. As the string is the same, tension in the string is also same. Now this is how system is if you come across this kind of system. So the trick I am going to tell you is just let's stretch it is along horizontal direction like this. m1 and m2 stretch along horizontal direction, and let me represent you that stretched system. So m2 and m1 is represented like this, and m2g is acting towards left and m1g is acting towards right. Don't say weight acts downward. I did already represented how weights will be represented on this diagram. After that only I am stretching the system. This system is after stretching the system which is shown in the left side diagram. So finally the blocks which are moving towards right because m1g is greater than m2g. So system is moving towards right with an acceleration a. Now let me consider acceleration formula. Acceleration is f net by m net. What is mean by f net? Is m1g is greater or m2g is greater? m1g is greater than m2g divided by total mass of the system m1 plus m2. So finally acceleration is going to be m1 minus m2 into g divided by m1 plus m2. This is the shortcut I would like to give you. See, it is taking so many steps just to make you understand. While you are representing, just observe whose object's weight is greater, then take the net force and total mass of the object, then you can find out acceleration very easily. Hope you understood, guys. Okay, let me solve this question and let me use this trick whether you understood or not. Okay, so let us see. So two bodies of masses 4 kg and 6 kg are tied to the ends of a massless string. The string passes over a pulley which is frictionless. Super. The acceleration of the system in terms of acceleration due to gravity is, okay, super. They are asking acceleration of the system. This is the diagram that they have given. I've already told you. You just stretch the system along horizontal direction, then you are going to get the answer very quickly. So this is how masses are given. So whose mass is greater? 6 kg is greater than or 4 kg is greater? Definitely 6 kg. So it's a weight acting downward and it is represented as a 6g, which is 4g. Definitely 6g moves downward with an acceleration a. 4g will move upward with an acceleration a. Let me stretch them system along horizontal direction. So you have to stretch the system after representing the masses. Don't stretch it before representing masses. Okay, 6g right side, 4g left side. As 6g is greater than 4g, system will move towards right. Okay, So 6g along 6g direction object system will move, then acceleration is equal to 6g is greater than 4g, that's why 6g minus 4g by total mass f net by m net. M net is 4 plus 6, which is going to be 2g by 10, which is equal to g by 5. This is the answer. Acceleration is equal to g by 5. So which option is correct? Option C is correct. This much simple it is if you use the trick that I have given. Hope you understood, guys. Okay, let me move on to the next question. So what is the next question they have given? So they have given a block inclined system and a block. Okay, super. Let me place that block on this inclined surface and let's solve what's the question they're asking. Super. This is how system is given. Let's say angle of inclination of this inclined surface is theta and the system is accelerating towards right with an acceleration a. Mass of this block is m. Question number 62 solution. Okay, let me read it out. So a block of mass small m is placed on a smooth inclined wedge ABC of inclination theta as shown in the figure. Okay, the wedge is given an acceleration a towards right. The relation between a and theta for the block to remain stationary. So what is the meaning of remaining stationary? This is what you have to understand. So for the block to be remains stationary, f net acting on the system must be equal to 0. Okay, so if f net acting, see already as object is at rest position, you have to make it, it may slide. Initially it is at rest position. If there is a possibility for sliding, so you have to displace this wedge towards right, then only this object may not displace on the inclined plane. Okay, let me represent. So whatever the number of forces acting on that block, its weight is going to be downward and it is represented as mg. Okay, normal reaction acting on this surface is on the block m is always perpendicular to the surface. Just remember this. Now a pseudo force will act on this block because of acceleration of this inclined plane, and which is represented as mass of that block and acceleration of the system. Okay, now this is how system is. Let me divide normal reaction itself into two components. That is the easiest way. Not because of easiest way, then only we'll get components exactly equal and opposite. Otherwise, if you divide mg into two different components, mg sin theta will come along the inclined surface. There is no compensating component. That is the reason I have to divide normal reaction itself into two components. So let's say this is one component and this is going to be another component. Now let me represent theta here. So how a theta is represented here? Okay, let me select this. Okay, now if this is theta, this is going to be 90 degrees. Observe carefully. This is going to be 90 minus theta. This angle is 90 minus theta. If this is 90 minus theta, this is going to be theta. If this is theta and this is 90 minus theta, if this is 90 minus theta, this is going to be theta. Okay, that is how we have to divide. And this is normal reaction, and this component is n cos theta. So this upward component is n cos theta. Next horizontal component is n sin theta. As the system is at rest position, we just have to equate the forces. Here n sin theta is equal to ma. N cos theta must be equal to mg. Okay, so just divide these two equations. What you are going to get? N will get cancelled out. Tan theta is equal to, mass also will get cancelled, a by g, and a is equal to g tan theta. This is the answer. Which option matches? A is equal to g tan theta. Option D is correct. Very good. Hope you understood. Next, question number 63. This is very interesting and somewhat tricky question. Try to understand, guys. So they are given a diagram like this. Let me represent that. So this is how two blocks system is given. So block A mass is 3m and block B mass is m. This is a spring system. First they are initially connected. Let me read out the question. Two blocks A and B of masses 3m and m are respectively are connected by a massless and inextensible string. Okay, The whole system is suspended by a massless spring. String is there, spring is also there. Okay. The magnitude of accelerations of A and B immediately after the string is cut respectively. Super. Now what they are doing is, first system comes to equilibrium position. Try to understand that if two blocks or any one block is suspended with the help of a spring, definitely first system will comes to equilibrium. After that whatever happens, you just have to find out the tension in the string or elongation, these things you can find it out. Okay, let me represent equilibrium position. So okay, so assume this is equilibrium position. So what is mean by equilibrium position? Upward forces are equal to downward forces, then F net acting on the system is equal to 0. Just observe block B. On block B, its weight acts downward, which is mg. Tension in the string is going to be T. So these two must be equal and opposite, then only system is in equilibrium position. Okay, next observe block 3, block A. On block A, so let me represent number of forces. One is tension in the string. Tension always represented away from the point of contact. Another one is its weight, which is equal to 3 mg. And the spring force direction is away from the point of contact, that is from A, which is equal to FSP. So if you observe here, tension in the string is going to be mg, and if you observe block B, block A, upward force is FSP, downward force is 3 mg plus tension in the string. Tension in the string is going to be mg, then 3 mg plus mg, which is equal to 4 mg. This is the spring force acting on that block. Super. So if that is the spring force and the tension in the string, let us see what's the question they're asking. They're asking after acceleration, magnitude of acceleration of A and B after the string is cut. Okay, super. So after cutting the string, let us see what is going to happen. After the string is cut, think logical. After string is cut, it is just after the string is cut. Okay, not after so much of time. Okay, let me represent that diagram again. This is right now the diagram is without a string. Now, so this is how block of mass 3m, block A, and this is how block B is represented. Its weight is downward. Again, 3m block is 3 mg, its weight is downward. There used to be string earlier. Now that string is absent because it is cut. Okay, na? So this is how the string is. Now if there is no string, what is going to be tension in the string? Tension in the string is going to be 0. Here it is T is equal to 0. Now spring force is present, and this spring force is in the opposite direction. So whatever the spring force which is present just before the cut of the string, just after the cut of the string is also spring force is going to be same, and it is equal to 4 mg. This is the only clue point that you have to understand. Spring force which is earlier stored just before and just after the string cut, string I am talking about, just before and just after string cut is going to be same, which is equal to 4 mg. Let me consider block A and block B separately. Mass 3m, downward force is 3 mg, upward force is spring force, which is equal to 4 mg. As 4 mg is greater than 3 mg, system will accelerate upward with some acceleration A. How to find out acceleration of A? F net by m net, that is 4 mg minus 3 mg divided by mass of this block, that is 3m. So m will get cancelled. Acceleration A is equal to g by 3. This is acceleration of block A. Let me find out acceleration of block B. Block B mass is m. Upward there is no tension. Tension is equal to 0. Downward it's weight. Then acceleration of block B is equal to, definitely this block will be moving towards downward direction with an acceleration AB. Then AB is equal to F net, that is mg divided by mass m, which is equal to g. So this block B is looking like it is under free fall motion. It is freely falling. after the string is cut. So which option is matching? First acceleration is g by 3 and next it is g. So option A is correct. Hope you understood, guys. Next, question number 64. Okay. A balloon with mass m is descending down with an acceleration a. Okay. Question number 64 solution. Let me represent a balloon. And it is descending down with an acceleration a. Super. And its mass is m. Its weight is going to be downward, which is represented as mg. Whenever any object is moving in a fluid, definitely there will be an upthrust which acts opposite to its motion. Okay, air is a fluid and balloon is moving in a air fluid. Definitely upthrust will act on that balloon in the opposite direction of its motion. Okay, as this balloon is moving downward, definitely mg is greater than upthrust. Let me write down that equation. According to Newton's second law, F net is equal to m into a, right? So what is F net here? mg minus F upthrust, which is equal to mass of that block into acceleration. This is equation 1. Okay, next step. Let me continue. So, and they said A is less than G. Okay. How much mass should be removed from it so that it starts moving up with an acceleration A? Now I have to remove some mass so that the balloon will move upward. I don't know how much mass I have to remove. Let me consider that mass that I am removing is x. So remaining mass is going to be m minus x. X is the mass that I am removing. Mass which is removed. Regarding ma? Very good. Which is removed. So its weight is again downward, which is going to be, is it mg or m minus x into g? It is now m minus x into g. Upward force is going to be upthrust, which is represented as F. And they said it should move upward with the same acceleration a. Okay. As motion of the object is upward, definitely upthrust is greater than its weight. So F minus m minus x into g must be greater. F must be greater. So F minus m minus x into g is equal to m minus x into acceleration. Okay, super. Let me substitute F here. Here F is equal to mg minus ma. Let me substitute this in this equation. So mg minus ma minus mg plus x into g, which is equal to ma minus xa. Super. mg will get cancelled out. Let me send it xa left side. It is going to be xa plus xg, which is equal to, send this minus ma right side, it will become 2 times of ma. Then x common, a plus g is equal to 2ma. Then x is equal to 2ma divided by a plus g. This is the mass that I have to remove so that the balloon will move upward with an acceleration a. So which option is correct? Option A is correct. Hope you understood, guys. Next, question number 65. 3 blocks with masses m, 2m and 3m are connected by strings as shown in the figure. Okay, let me represent those blocks. So mass m, another block of mass 2m, one more block of mass 3m. So these are moving upward with force F and velocity is v. Okay. After an upward force F is applied on block M, the masses move upward at constant speed. This is the hint. They are moving with a constant speed. Super. So if speed is constant, what about acceleration? Acceleration must be 0, right? Yes, it is. Okay. Then what is the net force on the block of mass 2m G is acceleration due to gravity. Okay, so the very first thing that you have to remember is, if speed of these blocks is constant, acceleration is equal to 0. This condition we already know. If acceleration is equal to 0, net force acting on each block must be 0. Net force acting on each block must be 0. Then only acceleration is equal to 0, right? So what is the answer for net force acting on to mass 2m? Definitely it should be 0, because acceleration of the system is 0. Hope you understood. Try to understand. It is very easy question. It looks like it is difficult, but it's very easy once you understand what is the exact meaning of velocity constant, acceleration is 0. So if you can understand, then it is going to be very easy. Hope you understood, guys. Next question is based on lift. Okay, so before solving this question, I would like to give you one hint. Okay, so let me give you that note. So whenever you come across lift numerical, just remember these 3 different cases. Observe these 3 diagrams. These are lifts and a person is standing inside the lift. Now look at the first case. In the very first case, lift is moving with a constant velocity, whether it is upward or downward, that's a secondary. Doesn't matter whether it is moving upward direction or downward direction. As velocity is constant or speed is constant, definitely acceleration of the system is going to be 0. Super. Is there any pseudo force acting on this person? No such kind of pseudo force. Let me represent normal reaction acting on the floor of the lift, which is in upward direction. Weight of this person is downward direction, where m is mass of this person. N must be equal to mg, then only acceleration of the system is going to be 0. It means spring balance which is arranged on the floor of the lift measures actual weight of the person. This is the meaning of the question. Okay, so and if they are asking tension in the supporting cable, tension is represented in the supporting cable, which is equal to, now you have to add mass of the lift also. Now T is equal to upward force must be equal to downward force, which is going to be M plus capital M into G. This is the way we have to find out tension in the supporting cable. It is tension in supporting cable. Hope you understood. Now look at the second example. In the second example, lift is accelerating upward. Okay, as lift is accelerating upward, definitely there will be a pseudo force acting on the person of mass smaller. It is going to be ma. Already weight of this person is acting downward, which is going to be mg. Now let me represent normal reaction, which is perpendicular to the surface of the floor. So normal reaction is equal to mg plus ma, and n is equal to m into g plus a. Super. This is going to be normal reaction. Then what is going to be tension in the supporting cable? T is equal to, you just had weight of this. If you add weight of the lift in addition to mass of this person, it is going to be m plus capital M into G plus A. This is how we have to find out tension in the supporting cable. Very important, and try to understand. Okay, next third case, lift is accelerating downward with an acceleration A. Now tell me what are the things which are present on this object. mg is downward. What's the direction of pseudo force acting on the object? As the lift is accelerating downward, definitely pseudo force will act in the opposite direction. That is shown here, which is ma. M is mass of that person, A is acceleration of the container. Normal reaction is perpendicular to the surface where man is standing. So from this, n plus ma is equal to mg, and n is equal to m into g minus a. What about tension in the supporting cable? Tension in the supporting cable is equal to T is equal to M plus capital M into G minus A. So this is the exact answer, and hope you understood, guys. This is how we have to find out tension in the supporting cable and normal reaction on the surface. So this normal reaction is nothing but weight of that person. So this is what balancing spring balance will measure. So normal reaction is the thing which we have to find out for the question they used to give for the measurement of spring balance. Hope you understood, guys. These three cases are very important in case of lift numerical. So let me solve this question. So what is the question they have given? They have given a person of mass 60 kg is inside a lift of mass 940 kg. Okay, super. Question number 66. Okay, so this is the lift. Mass of this person is 60 kg. Lift mass is 940 kg. Super. And person presses the button on control panel. The lift starts moving upward with an acceleration 1 meter per second square. Super. Lift starts moving upward with an acceleration 1 meter per second square. Super. If G is 10 meter per second square, the tension in the supporting cable is. So which of the following cases it is suitable? I think case 2. As lift is accelerating upward, you just can use direct formula. So hope you understood this explanation. So tension in the supporting cable, I am writing direct formula. It is going to be M plus capital M into A plus G. So pseudo force is opposite to motion of the container. That is nothing but lift. So mass of the person is 60 kg. Mass of lift is 940 kg. Acceleration is 1. Acceleration due to gravity is 10. So 940 plus 60 is 1000 into 11. It is going to be 11,000 Newton. This is the answer. Which option matches? Option C is correct answer. Okay, next question number 67. Super. So the mass of lift is 2000 kg. Okay, so again same question, lift numerical. So mass of the lift is that is capital M, right? Okay, so capital M is equal to 2000 kg. Okay. The tension in the supporting cable is 2800 newtons. Okay. Tension in the supporting cable is 2800 newtons. Now, then its acceleration is super. So what is the direction of acceleration? As the tension in the supporting cable is greater than mass of, let me represent weight acting on this lift, which is going to be 2000 into G, right? G is equal to 10, which is going to be 20,000. So this is actually tension in the supporting cable is 28,000. They have been 28,000 newtons. So as the system tension in the cable is greater than weight acting on this body, definitely T is greater than weight. So T minus, let me represent that. That is 28,000 is greater than 20,000. So 20,000, which is equal to 2000 into acceleration. So F net is equal to MA formula. That's what I used. F net is equal to MA. This is F net. So it is going to be 8,000 is equal to 2000 into A, and A is equal to 4 meter per second square. This is the way to find out the answer. Hope you understood. Check out once again if you didn't understood. Next step. A block of mass small m is placed on a smooth wedge of inclination theta. Super. The whole system is accelerated horizontally so that the block does not slip on the wedge. The force exerted by the wedge on the block will be. Super. Question number 68. We already did solve this kind of questions. Which question we did solve? Same type. This one. 62. What is the answer that we got for this question number 62? Acceleration with which this system should displaced so that block will be rest on the inclined surface is A is equal to g tan theta. This is the answer. We can use that answer. You just check out those two questions. Both the questions are same. Only difference is they are asking force exerted by the wedge on the inclined on the block. That is what they are asking. So what is mean by force exerted by the wedge? Force exerted by the wedge on the block is going to be normal reaction. This is what we have to find out. Now let me represent type of forces which are acting on this block, then we'll go ahead. So weight acting on this block, of this block is going to be mg, which is downward direction. Now pseudo force acting on this block towards left against the direction of the motion of the wedge, which is m into a, which is equal to m into g into tan theta or sin theta. It is going to be m into a, let me keep it as it is, ma alone. Okay, so m into a. Now I need to find out normal reaction. To find out normal reaction, let me divide mg and ma into two different components. Now I need to find out this component of mg. Mg is going to be, this is going to be mg cos theta, and this component is mg sin theta. Hope we know this. So if this is theta, this is also going to be theta, right? So let me divide this also into two components, which is going to be ma sin theta. Super. Then normal reaction is equal to, try to understand this theta and this is the same. So n is equal to ma sin theta plus mg cos theta. We know that a is equal to g tan theta. Let me substitute that. N is equal to m into g tan theta. Tan theta can be replaced as sin theta by cos theta into sin theta plus mg cos theta. Okay, so which is equal to, let's common mg here, mg into sin square theta plus sin this cos theta here, it is going to be cos square theta divided by cos theta. Sin square theta plus cos square theta is going to be 1. Then n is equal to mg by cos theta is the force exerted by the wedge on the block. Which option is correct? Option D is correct. Hope you understood, guys. Question number 68, question number 62. Both are similar. Only thing in question number 68 extra they are asking is, they are asking force acting on the block due to wedge. Super. Next, question number 69. A man weighs 80 kg. He stands on a weighing scale in a lift which is moving upward with a uniform acceleration 5 meters per second square. Super. Already given types of numericals which comes based on lift. Look at this, question number 69. Let me solve that. So what's the weight of this person? I mean, weighing, he is weighing 80 kg. That means they are given mass. Okay, super. Now lift is accelerating upward with an acceleration 5 meter per second square. It is, what would be the reading on this scale? They are asking normal reaction. That's the meaning. Reading on the scale is nothing but normal reaction on the surface. Normal reaction is a balancing weight. So let's say this is n. Weight acting on this person is downward, which is going to be m into g. As this lift is accelerating upward, there will be pseudo force which is acting in the opposite direction, ma. Now normal reaction is the thing which we have to find out. That is going to be reading on the scale. Then n is equal to ma plus mg. So ma 80 into 5 plus 80 into 10, which is equal to 400 plus 800, which is equal to 1200 newtons. So which option is correct? Option D is correct. Hope you understood, ma. Next type of numerical they have given based on monkey. Super. A monkey of mass 20 kg is holding a vertical rope. Super. The rope will not break when a mass of 25 kg suspended from it, but will break if the mass exceeds 25 kg. Okay. Look at this. They are given a hint. The rope will not break when a mass of 25 kg is suspended from it. What does it mean, sir? Tension should not be greater than 25 into g. That is the meaning. They are given mass. They are not the tension and not weight. So that means T is equal to, it should be m into g. And this value they have already given, that is going to be 25. This is the maximum limit. 25 into g is the maximum tension in the string. Okay. They are asking what is the maximum acceleration of this monkey along the rope to climb up. Super. So tension is T. So weight of this monkey is going to be downward. Weight of the monkey is going to be downward, which is going to be, what's the mass of the monkey they have given? Mass of the monkey they have given is 20 kg, right? Okay, so 20 kg, then it is going to be 20 into g is going to be its weight. As monkey is moving upward, which is going to be greater? Is tension in the string is greater or weight of this monkey is greater? Definitely tension is greater. Then tension minus weight of that monkey, that is mg, which is 20 into g, which is equal to mass of that monkey into acceleration. Tension is going to be 25 into g minus 20 into g, which is equal to 20a. Then it is going to be 5g is equal to 20 into a. Then a is equal to 5 4s, then g by 4, g is 10 by 4, which is equal to 2.5 meter per second square. So which option? Option D is correct. Super. Very good. Next, question number 71. It's again lift numerical. Already given a trick how to answer it. Okay. A lift of mass 1000 kg which is moving with an acceleration 1 meter per second square in upward direction. Super. What's the mass of the lift? M is equal to 1000 kg which is moving upward with an acceleration 1 meter per second square in upward direction. Then tension developed in the string which is connected to the lift is. They are asking tension in the string, nothing but balancing string. So this is what they are asking. Super. Did they said any person is inside the lift? No, they didn't said anything. Only they have given mass of the lift. Okay, then definitely there will be a pseudo force which is acting on it, and that pseudo force is mass of this lift into pseudo force, acceleration. Then its weight is acting downward, which is going to be m into g. Then tension in the string supporting cable, which is equal to m a plus m g. So what's the mass they have given? It is going to be 1000. What's the acceleration they have given? So acceleration is 1 meter per second square. Did they give acceleration due to gravity? No, they haven't given. Then 1000 into 9.8, which is equal to 1000 plus 980, and answer is going to be 1980. No, it's not 980, 9800. Now 9800 plus 1000 is going to be 10800. So Newton. This is going to be answer. Which option matches? Option B is correct. Very good. Next, let me solve question number 72. Let us see how to answer. They gave pulley system. This is how the pulley system is given. What's the question they're asking? Two masses as shown in the figure are suspended from a massless pulley the acceleration of the system when masses are left free. Okay, I told you whenever you come across this kind of question, you just first represent weights acting on this. Okay, so one is 5 grams, another one is 10 grams. Did they represented weight itself? Two masses as shown in the figure, they are masses. In question they have already represented weights, that is 5 into g, 10 into g, which are acting downward. It's not 5 grams, it's 5 kg only, so 5g, and this is going to be 10g. I told you, use the trick here, you just stretch the system along horizontal direction. Now this is going to be 5g, and right side it is going to be 10g, and this is represented like this. So as 10g is greater than 5g, definitely system will accelerate towards right or towards left. It is going to accelerate towards right. Then a is equal to 10g minus 5g divided by total mass of the system. Total mass of the system is going to be 5 plus 10. So 5g divided by 15, and a is equal to g by 3 is the answer. You just use this trick here. I've already given the trick, right? Just use it. We are going to get the answer very easily. Okay, next question number 73. Let us try. You just try by pausing the video, then you'll get the concept also. A mass of 1 kg is suspended by a thread, okay, lifted up with an acceleration 4.9 meter per second square, lowered with an acceleration 4.9 meter per second square. Now what's they're asking? The ratio of tensions. Super. Let me represent the diagram. Let me show you in the form of two different diagrams, case 1 and case 2. Mass 1 kg is suspended by a thread. It is lifted up. Right now it is lifted up with an acceleration 4.9 meter per second square. Okay, now if it is lifted up, tension in the string is upward, weight acting on this object is going to be downward. So which is going to be 1 into g is going to be 9.8. So finally weight is going to be 9.8, upward it is t. So which is greater? Definitely tension must be greater. There will be a pseudo force which acts in the opposite direction, which is equal to 1 into 4.9. Then tension in the string is equal to 9.8 plus 4.9. Hope you remember. This is like a lift accelerated upward. Next, second case. In the second case, it is lowered with an acceleration 4.9. Super. 4.9 meter per second square. Pseudo force right now acts in the opposite direction, which is 4.9. 1 into 4.9, mass into acceleration, weight acting downward, which is going to be 1 into 9.8. So tension in the string is upward. So finally tension in the string is going to be T is equal to 9.8 minus 4.9. So let's say this is T2, T1. Now let me find out the ratio. So how the ratio they're asking? They're asking T1 by T2. Okay, T1 divided by T2, which is equal to T1 is 9.8 plus 4.9 divided by 9.8 minus 4.9. We know that 9.8 can be represented as 2 times of 4.9. So if you write down like this, 2 times of 4.9 plus 4.9, it is going to be 3 times of 4.9. Here downward, 2 times of 4.9 minus 4.9 is, it is going to be 4.9. 4.9 will get cancelled out. Answer is going to be 3:1 ratio. This is the shortcut way to answer this. Don't waste your time in multiplying or adding 9.8 plus 4.9. It's a waste of time because 4.9 and 9.8 are twice, right? 9.8 is twice the 4.9. So this is how you can think. Answer option C is correct. Very good. Next. Question number 74. A mass capillum is placed on a very smooth wedge resting on a surface without friction. Okay. Once the mass is released, the acceleration to be given to the wedge so that capillum remains at rest is super. Wow, this numerical again came. Question number 74 and question number 68, question number 62 are of same model. Now, this block is released now. In which direction I should accelerate this wedge? This is wedge and this is block. In which direction I should accelerate this wedge so that the block will be rest? If I accelerate towards right, then this block will fall down. I should not accelerate like this. Then in which direction I have to accelerate this wedge? Is this wedge must be accelerated towards left with some acceleration A. A pseudo force acting on this block is going to be MA. Normal reaction is perpendicular to the surface, so which is represented like this. This is normal reaction. Its weight is downward, which is equal to mg. Already I did give derivation for this. What should be the acceleration? Acceleration must be equal to g tan theta. You just go through question number 62, 68 and 74. Which option matches? Option A is correct. You should accelerate the wedge towards left, and that acceleration is equal to g tan theta. Next question number 75. A monkey is descending from the branch of a tree with constant acceleration. Super. Assume this is the monkey and that's branch of the tree. So now this monkey is accelerating down, descending in the sense it is moving down with a constant acceleration. Okay, so this is acceleration is constant. If the braking strength of branch is 75% of weight of the monkey. Super. This is the hint. So they said braking strength of branch is 75% of weight of the monkey. Let me represent weight of the monkey as mg. I am assuming mass of this monkey is m, and its weight is mg. They said braking strength of the branch, which is tension in the string, which is equal to 75% of weight of this monkey. This is the way how you have to represent. What's the question they're asking? The minimum acceleration with which monkey can slide down without breaking the branch. Okay. Now, as monkey is moving down, which is greater? Mg is greater or tension in the string is greater? Definitely Mg is greater. So Mg minus tension, which is equal to mass into acceleration. Mg minus T is 75% of mg. So this is the way to represent 75% in the sense per 100 by 100 of is into mg, which is equal to m will gets cancelled out. 75 by 100 is nothing but 25 3s are 25 4s are. So which is can be represented as 4g minus 3g divided by 4, which is equal to a. Then a is equal to g by 4. Which option matches? Option C is correct. Super. Next. Question number 76. This question came in 2021 NEET. Okay, so a ball of mass 0.15 kg is dropped from a height 10 meter, strikes the ground and rebounds to a same height. Super. Question number 76. A ball of mass, what's the mass of the block? 0.15 kg, which is dropped in the sense initial velocity is equal to 0. So what is the height from which it is dropped? It is dropped from a height of 10 meter. Okay, so what's the question they're asking? So magnitude of impulse. What is the formula for impulses? Impulse is nothing but change in momentum, which is equal to final momentum minus initial momentum. What's the Formula for momentum. Momentum is mass into velocity. So mass into final velocity minus initial velocity. Final velocity in the sense velocity just before rebounds, velocity, Vf is velocity after rebounds, Vi is velocity before rebounds. Okay, let me find out velocity with which it is going to hit this surface of the ground. Okay, so how to find out velocity? We can use the equations of motion. V square is equal to u square plus 2as. Velocity, initial velocity is equal to 0, then v square is equal to 2 into, I have given reference directions in motion in a straight line. I'm just following them. So it is going to be h minus h I have to use because object is moving downward. So v square is equal to minus into minus, it is going to be plus 2 into g value given, h value is 10, then v is equal to root of 200, which is equal to 10 root 2. This is going to be the velocity with which it is going to hit the ground. So this is the initial velocity. They said it is going to bounce back with the same velocity or a different velocity. Same velocity, because it is about to reach to the same height. This is the initial velocity. They said in the question very clearly, right? So after rebounds, it is going to reach same height. What is the meaning of it is going to reach same height? It is going to bounce back with the same velocity, but only, magnitude of velocity is going to be same. So only problem is its direction. Velocity with which it is moving down, let me consider that is as a negative. Velocity with which it is going up, it is going to be positive. So this is, I am considering it is as positive, and this is going to be negative. Okay, let me find out change in momentum. So that is what they are asking. Change in momentum is mass of this object 0.15 into final velocity. So final velocity minus initial velocity. So velocity is a vector quantity. You must represent with direction. Final velocity is 10 root 2. Initial velocity is, it is going to be hit the ground in downward direction. That's why I am taking it as minus 10 root 2. So finally it is going to be 0.15 into 2 times of 10 root 2, which is 0.3 into 10 root 2, which is equal to 3 root 2. Root 2 value is 1.414. 3 into 1.414, which is equal to 4.2 kg meter per second. So this is the change in momentum. Hope you understood, guys. They said it is rebounding to a same height. That is the reason final velocity and initial velocity before rebounds and after rebounds, they are same. Hope you understood. That is the answer. Next. Question number 77. Already we solved this kind of numerical. Let me solve it again. Question number 77. They said a shell of mass small m initially at rest. Okay. M initially at rest. So what is the meaning of at rest? Initial velocity is equal to 0. If initial velocity is equal to 0, what about initial momentum? Initial momentum is also equal to 0. Now a shell of mass small m initial at rest, it explodes into 3 fragments having masses in the ratio 2:2:1. Okay, now it is exploded into 3 different particles. Those are having ratios. I am representing here m1 is to, m2 is to, m3 is equal to 2:2:1. Okay. Now, if the fragments having equal masses fly off along mutually perpendicular directions with speeds v. Okay, super. So 2 particles are having same masses. Those are m1 and m2. Let me take this is m1 and this is m2. They are moving perpendicular with each other with speeds v. Okay, let me take those perpendicular directions like this. Okay, and this is going to be the particle of mass m3. Okay, now what's the question they're asking? The speed of the third fragment. Okay, I don't know speed of the third fragment. That is going to be represented here with v3. Okay, so as this bomb is exploding because of internal forces, external force acting on that block is 0, As external force is equal to 0, change in momentum is equal to 0. That is final momentum minus initial momentum is equal to 0. Then initial momentum, or else you can write down it is as final momentum is equal to initial momentum. We know that initial momentum is equal to 0 because bomb is initially at rest, or shell is initially at rest position. So I have to write down final momentum. Momentum is a vector quantity, so that's why I must represent with a direction, that is m1 v1 bar plus m2 v2 bar plus m3 v3 bar, which is equal to 0. I don't know individual masses, but I know masses ratio. I've given a trick to find out masses of individual objects if they have given ratio. Let's say mass of the block is m, then how to find out m1? m1 is equal to ratio, that is 2 into mass of the object divided by sum of that ratio, so that is equal to 5. Then what about m2? m2 is equal to 2m by 5. m3 is equal to m by 5. This is the way to find out mass. I have already given this trick. You just go through the first part of laws of motion. You can understand how I divided this. Now m1, what is m1 mass? m1 is 2m by 5 and it is moving along x direction, so it is v I cap. Next m2 is 2m by 5, it is moving along j cap direction with the same speed. Then they said two equal masses are moving in perpendicular directions with the same speed, right? That's why I represented like this. Now m3 is m by 5. I don't know the direction of v3, okay, which is equal to 0. So if you send right side, m will get cancelled. I mean m by 5 also gets cancelled, 5 5 5. Then v3 bar is equal to minus 2v I cap minus 2v j cap. They are asking magnitude options. They have given this form of magnitude. It is going to be 2v square plus 2v whole square. So final answer we are going to get, so 2v comes outside, it is going to be 2v root 2 or 2 root 2v is the answer. So which option matches? 2 root 2v. Two options they have given same, so option 2 and option 3 are correct. One of the option is different actually. So in this PDF these two options they have given same, so one of the option is going to be correct. 2 root 2 into v is the correct answer. Hope you understood. Wow, what a nice question they have given. So very interesting and makes us so happy while we are solving this kind of numericals. Observe the question, so amazing question. Calculate the maximum acceleration of the moving car so that a body lying on the floor of the car remains stationary. Okay, on the floor of the car one object is remaining stationary. Okay, super. Let me consider mass of that block which is on the floor of the car is m, and car, let's say it is accelerating towards left. Like this only. Let's say that acceleration is going to be a. We don't know what's that acceleration. What should be that acceleration? That's what we have to find out. If this car accelerates towards left, definitely block which is on the floor of the car will accelerate towards left because of pseudo force. Very good. In which direction it will accelerate? Towards right. So mass of that block into acceleration. As this block is on the floor of this car, they have already given coefficient of static friction between the block and the floor is 0.5. Super. They have given coefficient of static friction which is equal to 0.15. Super. As this block is trying to slide towards right because of pseudo force acting on it, there will be a frictional force which tries to stop its motion, which acts in the opposite direction of pseudo force. They said block remains stationary. It means those two forces must be equal and opposite in direction. Then just equate both of them. Then F is equal to ma. Now what's the direction of normal reaction? Normal reaction is always perpendicular to the surface, right? N, and which is equal to mg. Okay, let me represent all these things. So here it is. F is equal to formula for frictional force mu into N, which is equal to MA. And so what's the value of N here? So mu into mg, which is equal to mm will get cancelled out. Then A is equal to mu into g. Mu value they've already given 0.15 into acceleration due to gravity 10, which is equal to 1.5 meter per second square. This is the acceleration with which that car should accelerate. That's the maximum acceleration of the car, so that block which is on the floor is going to be at rest position. Yes, successfully we completed third part also. I just hope you utilize it. It will definitely helps you and boost your calculations methodology. See, this kind of procedures and this kind of analysis, it is not available in materials or in textbooks. The way how I am going to solve, the way how I see the things is a little bit different from the material. Try to understand and hope you developed your way of thinking also in a different way. So how you are going to understand it may be also different. Your way of thinking also may be different. You just think like that, definitely it's not going to be a difficult thing. Thank you so much for having listening these classes with the patience. Have a nice day. So as soon as possible, I'm going to upload work energy power also. Keep on listening, watching these videos. Thank you so much.